So we are writing the ages according to the non-decreasing weight. So we have inserted this. Then the next stage is between 2 and 3, and the weight is 7. So first of all, we will compare this weight 7 with the first element. The first element 4, which is less than 7, so we will not change the order here. Then the next element is 1, 2, whose weight is 8, which is greater than the weight of the age 2, 3. This weight is 7. So after 0, 1, we will insert this new age, which is 2, 3. So what will be now the order of the ages according to their increasing order or non-decreasing order? So first 0, 1, weight is 4. Next stage will be 2, 3, weight is 7. Then the age is 1, 2, which is 8. So next stage we will consider, suppose 3, 4, connecting vertices 3 and 4, and which has the weight 9. So 9 means it will come at the last position of this age in this order of the ages. So 3, 4, this age has weight 9, which is maximum among all of these ages. Next is, suppose consider 4 to 5, which has weight 10, so which is maximum among all these ages. So we write later here 4, 5, this is an age, and the weight is 10. Next stage we will consider is 5, 6. First we will, this weight is 2. So first we will consider 2 with respect to first item in this list. 2 is less than 4. So weight 5, 6 will come at the first of the list. So here I am writing the ages. 5, 6, weight is 2. Then 0, 1, weight is 4. Then 2, 3, weight is 7. Then 1, 2, the weight is 8. Then 3, 4, weight is 9. Then 4, 5, which is 10. So after that, the next age we want to include, suppose 6, 7. Connecting vertices 6 and 7, whose weight is 1. So it will come first of the list. This position, it will come first of the list. So how the list will look now? It will be 6 to 7 has weight 1. Then other remaining items in the list will be unchanged. 5, 6 has weight 2. Then 0, 1 has weight 4. Then 2, 3 has weight 7. Then 1, 2, weight is 8. Then 3, 4, weight of this age is 9. Then weight of age 4, 5 equals to 10. Next age we will consider connecting vertices 0 and 7, and the weight is 8. So 8 will be compared with first item in the list. 1 is less, so we will go to the next item. 2 is less than 8. Then we will come to next third item. 4 is less than 8. So next item 7 is less than 8. Next item, this age 1, 2, which has weight, which is equals to the weight 0, 7. And the next stage is 3, 4. 3, 4, which has weight 9, which is greater than this weight of this age. So we will include this new age at this position. So we will include age at this position. So what will be the sorted list? The list is now 6, 7 age has weight 1. Then 5, 6 age weight has 2. Then 0, 1 age weight is 4. Then 2, 3 has weight 7. Then 1, 2 has weight 8. Then 0, 7 will be inserted into this position because it has the weight 8, and the next age is 3, 4, which has weight 9, which is greater than 8. And the last age is 4, 5, which weight is 10. Then the next age we consider, suppose 1 to 7, which has weight 11, which is the maximum among all the ages in the list. So we will write that age 1 to 7 at the last of the list. So I am writing the age 17 at the last position and its weight is 11. Next stage we consider, suppose here 2, from 2, so from 2 there is an age 2 to 8 which has weight 2. So we will consider this age now 2 to 8 with weight 2, which is not greater than this age 6, 7 which has 1. Next stage 5, 6 has equal value, that is 2. Next stage 0, 1 age has weight 4. So we will include this new age at this position, that is just before of the age 0, 1 which has weight 4, which is greater than the current age. So current is 2, 8 will be inserted into this position. So what will be the list will now look like? So the list will be 6, 7 has minimum weight 1, then 5, 6 this age has weight 2, then age 2, 8 will be inserted which has weight 2, then all other remaining items in the list will be same as it is. So 0, 1 this age has weight 4, then 2, 3 has weight 7, then 1, 2 has weight 8, 0, 7 has weight 8, then 3, 4 has weight 9, then 4, 5 has weight 10, then 1, 7 which has weight 11. So this is the current list of the ages sorted according to their weight. Now the next node I want to consider, suppose 2 to 5. So the next node I want to consider is 2 to 5 and whose weight is 4. So 6, 7 weight is 1, so will not change its position. This age 5, 6, 2 less than 4, so we'll go to next stage. 2, 8, 6, 2 weight 2, so we'll go for next stage. 0, 1 has weight 4 which is equal to this considered age. The next stage is 2, 3 which weight as 7 which is greater than the current considered age. So we will insert the current age at this position just before the age 2, 3. So how the list will look like? It will be first 6, 7 which has weight 1, then 5, 6 will have weight 2, next 2, 8 weight is 2, then 0, 1 weight is 4. Now the ages what we have considered 2 to 5 which weight is 4. So we'll insert this age here 2 to 5 weight is 4. Then the remaining items in the remaining ages in this list will be same as it is. Next stage is 2 to 3 weight is 7. Next stage 1 to 2 weight is 8. Then 0, 7 weight 8. Then 3, 4 weight is 9. Then 4, 5 weight is 10. Then 1, 7 weight is 11. So we will consider the next stage, suppose 6 to 8 which is not included in this list and the weight is 6. So we will do comparison at which position in the list this age which is 6 to 8 whose weight is 6 that will be inserted. So 1, 2, 2, 4, 4 then 7. So this age 6, 8 which has weight 6 will be inserted before the age of this 2, 3 because it has weight 7. So how this list will look like? Sorted list of ages according to their weight. So 6, 7 will have weight 1, 5, 6, 2, 28, weight is 2, 0, 1, weight is 4, 2, 5, weight is 4, then 6, 8. This age will be inserted before this age 2, 3, which is 7. So 6, 8, weight is 6. Then the remaining ages in the list will be same as it is. So what will come? 2, 3 has weight 7. 1, 2 has weight 8. 0, 7 has weight 8. Then 3, 4 which has weight 9. Then 4, 5 weight is 10. Then 1, 7 weight is 11. Okay. So I think still now one age has yet to be included, which is this one. That means connecting vertices 3 and 5, and its weight is 14. So which age I have to include now, which is connecting vertices 3 and 5, and the weight is 14. See, if you see the list here, or in this list, the 14 has the highest weight among this according to this list. So this age 3, 5, whose weight is 14, will come at the end of the list. So we will add this age in this sorted list, and whose weight has a maximum 14. So count, first check well all the ages of the graph have been listed here or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think one more age is missing from that graph. So what is that? 2, 5. 2, 5 included. 6, 8 also have been included. So which one? There are how many ages if we count? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, one age is I have not included, which is 7, 8. This age, 7, 8. This weight is 7. So the last page that I have to consider is 7, 8. Connecting vertices 7 and 8, and its weight is 7. Now see the list. This is 1, 2, 2, 4, 4, 6, 7, then 8. So the considered vertex 8, 7, 8 will be inserted this position of the list. That means just before age 1, 2, which weight is 8, greater than this age. So what will be the list now that I will write here in freshly? So what will be the sorted list now? 6, 7 is the first minimum weighted age. Then 5, 6, the weight is 2. Then 2, 8, weight is 2. Then 0, 1, weight is 4. Then 2, 5, 4, weight is 4. 6, 8, weight is 6. 2, 3, weight is 7. Then this age 7, 8, whose weight is also 7. Then remaining ages in the list will be as it is. 1, 2, weight is 8. 0, 7, 8, 3, 4, 9, 4, 5, weight is 10. 1, 7, weight is 11, and 3, 5, weight is 14. So that is the complete sorted list of the ages for that particular graph. Now the first stage, what we have written, that sort or arrange all ages of the graph in non-decreasing order. So this step is over. Now after this step, what we will do? We will go on adding the ages sequentially. Sequentially means started from the least weighted edge, then gradually going through the list to the bottom, so that we are going to add those edges which will have the minimum weight. So the total weight will be minimum. If we go on adding those edges which has the least weight than the remaining all of the edges, then obviously the total weight will be minimum. So that is the concept why we have sorted this edge in non-decreasing order, so that we can get a minimum cost spanning tree. If we start from the least weighted edge and go on adding those edges according to according and going through this list, we will go on adding the least weighted edges. So the total weight should be minimum. But here is the criteria. The criteria is that while go on adding the edges according to their weight, there may create a cycle. So if there is any edge, so that if we include that edge in the spanning tree, it creates a cycle. So we will not add that edge, rather we will discard that edge and we will go for the next weighted edge, next higher weighted edge, because the previous less weighted edge creates a cycle. So we cannot add that less weighted edges. So we have to discard that edge and we will go on to the list for the next higher weighted edges. So in this way, when number of edges we have added in the spanning tree becomes equals to the number of total vertices minus 1, then we swap our procedure and the spanning tree is constructed. Because in spanning tree, for this particular example, there are 9 vertices. So just to connect 9 vertices without any cycle, only 8 edges are sufficient. So we will consider adding on edges from the sorted list as long as we are getting a total 8 edges. And while we are adding the edges, we have to keep on remember that it should not create a cycle. So while we are considering a edge to be added in the spanning tree or not, we have to check it does not contain any cycle. Then only we will add that edge in the spanning tree. Otherwise, we will go for the next weighted edge. So here the next step is that consider an edge from the sorted list according to their weight, and if it does not create any cycle, then add that edge into that corresponding spanning tree. So here now needs the mechanism how to find out whether an edge is creating a cycle. If we add that edge in that spanning tree, then it will create a cycle. How to detect that? So detect that there is a particular mechanism, there is an algorithm, which is the algorithm we will use is union find algorithm. So what is that algorithm? That I will see, and when it satisfies that according to that algorithm, if it finds that if that algorithm says that yes, this age if we add this age it will create a cycle, then we will not add that age, then we will go for the next weighted age. Okay, now this is the concept. Now while considering these ages according to their weighted in non-decreasing order, we will, before adding every age, we have to run that algorithm whether it will create a cycle or not. If it does not create any cycle, then we will add it. Otherwise, we will discard that age and go for the next higher weighted age. Okay, that is the point. Now, so what I am doing, so this is clear. Now I am just drawing the graph, only the vertices of the graph, because in that spanning tree of a particular graph, all the vertices will be present, but only the number of edges will be different than the graph. So